Today, I'm going to tell you a story about a big hack that shook the market and the industry, as well as how we tried to avoid being a target of that hack. Name is Alex. I'm a contributor at Lido DAO. I'm a DAO Tech Infra lead, lead of the team that makes sure that governance rails are oiled up and ready for the proposal train arrival. So what happened? Happened grand theft crypto. The biggest hack in terms of extracted value in the history was made not by exploiting some smart contract, but by hacking an off-chain part of the on-chain operation. And why bother? Why is it important for Lido? Let's add a bit of context here. Lido is a liquid staking protocol on Ethereum, currently holding around 9 million ETH. It's a middleware connecting users with ETH and node operators, and it allows to stake any amount of ETH, get staked ETH, and use it across the DeFi. And the whole beauty is governed by Lido DAO. What is Lido DAO? This is the question, and the answer is a topic of another talk. So we'll focus on just on one part of Lido DAO, which is, or are, committees. And there are more than 20 committees within Lido DAO. Each committee has its own purpose, and almost each one has its own multisig. And here you can see a brief list of operations that committees are executing. Of course, the most popular operations are grant issuance. For example, it could be ecosystem grant or reward distribution or some kind of compensation. So any token transfer is under that category. Also, we have within committees emergency breaks that allow to a special mechanism that allow to pause protocol for some time, as well as easy track motions, which are part of governance process. Easy track is an optimistic governance framework made for optimizing some mundane processes within DAO and other smart contract interactions. And some those operations are holding some risks. Of course, the biggest risk is to lose funds. Currently, the number is, the maximum amount is 8 million USD. And to make like unintentional procedures, for example, to pause different parts of protocol, we don't want that to happen. So when we heard the news about the hack, the reaction was immediate. And all on-chain operations were put on hold. And we started to think, how can we make sure that our multisig transactions are valid, and how to make sure we are not signing something bad. So the main problem, the main issue is we can't trust safe UI and safe API anymore. This is the bold statement, but at the moment they were compromised, and we were not sure that we can trust them. So we need to find a way to basically to work with safe UI without trusting this UI. And this problem could be split into 3 questions that we need to answer. First answer is how to verify transaction without the safe. Second question is how to implement it fast, because the clock's ticking, all operations were put on hold, and we want to unlock this process as soon as possible. And third question, standard one, how can we avoid worsening security? Because if we want to improve something, if we want to add a layer of defense, we could easily make the surface of attack bigger and unintentionally add some attack vectors. So in trying to answer those questions, our first step was just opening Twitter. User with the nickname PC Versaccio made a script, a command line interface to check and to verify safe transactions. Basically, what I mean by verification is the process of calculating hashes that are visible in the safe UI as well. We'll get to them a bit later, but just to add context to this solution, later, after the author posted the script, audit company Cyphrin made its fork, and it was better because it contained the offline mode, which allowed to calculate those hashes without using Safe API. So we started to try and to play with this script. We reviewed the code, and it was good enough for us to implement. This is how the result of the script looks like. And you see in the red, there are 3 hashes that we'll focus on. Basically, the process looks like this. You see those hashes in the safe UI, and you add in the second source of truth, generating from this place, you're generating those hashes, and you see whether they're matching themselves or not. If there is a match for all 3 hashes, then you're good and you can proceed. But if not, you need to abort immediately and seek for help. Something is bad. And let's see what those hashes are. So you see on this screenshot, this is just an ordinary transaction of sending one USDT from one address to another. We have all our favorite fields, like toValue, call data. We have a type of operation and some nonce and some safe-related fields. But below all of that, we see those hashes. And let's see how can we calculate them. This is all possible because of EIP 712. So those 3 hashes, it's very easy to get them without interacting with some, for example, remote server. You just need to know the safe config. So some values related with safe itself to get the domain hash. And then you need all the transaction data to get the message hash. And if you wrap both those hashes into Ketchup function, you'll get safetyx hash. So those are 3 hashes that we need to verify. This is all great, but the question is, will we use the CLI solution with more than 100 of signers within Lido DAO? I think the CLI could be very tedious. And if you use script like this, it's a very good temporary solution if you need to act immediately. But if you want to improve process somehow, you need to come up with something else. Of course, the most obvious answer is make some kind of UI. But there is an issue, which is really a feature, not a bug. We are cooking slowly but surely, because the standards are very high. And the process is a multi-step with reviews and audits and all the checks, all the checklists. So we can't just make something, deploy it to, for example, to Vercel and say, yeah, this is good, we can use it, we approve it. If we want to do something, if we want to do something big and serious, we need to consider the whole timeline for doing that. And that wasn't the situation there. So what we did, the result of the hard work, was a hash calculator. It is a very simple tool which serves only one purpose, to generate those hashes. It has 0 dependencies. Actually, it has one, but it's embedded in the script itself. It is fully offline. Basically, it is the HTML file that you can download and use. You can upload it into like some remote source. You can upload it into IPFS. You can use it locally, whatever you like. And it's pretty easy to run. You have basically an input field for each part of the safe transaction and the button. You generate hashes and compare them with what you see in the safe UI. This is the QR code for those who are interested in taking a look. It is a public repo, and it's open source, so all suggestions are welcome. And then, so what's next? It's the question that popped up like immediately. Because the solution was good enough for it to implement within the signers, within the committees. But it is still pretty raw, and we were thinking on how can we improve the process and make it easier. The problems that we saw is, first problem, it's not a most important one, but it's a bad developer experience because you have all the code in a single file. The second problem is because of browser interface, we are using browser to render the application. We are vulnerable to some browser hacks. And we need to copy-paste the data. That part can also be poisoned. So we need to be still extra careful. And we need to validate all the fields that we are putting from one window to another. But still, even those are problems that we have, the solution is good enough to answer those questions that we had previously. And the improvements that we see, Safe is cooking as well. And I hope they made access to the remote server more strict since then. But on the side of UI, they now have a feature that allows you to basically copy the whole transaction payload and paste it in different forms and even download it as a JSON file. So it is very more accessible because at the time that we were making this tool, it was like they don't even show you the whole hashes. They show like first 4 symbols, then dots, then last 4 symbols, and they have a copy button which can be easily hacked if someone has like an access to server like Bybit hacker had. So now it's better, 10 times better, and we can evolve our solution to be on par with the updated Safe UI. But the end game for such process, as I see it, is a full-scale solution that will include not only some kind of tooling for checking the code data, checking the multisig hashes, but comprehensive guide for all signers with all steps and described caveats, and also some kind of monitoring solution, because it's very important to see what's going on within those like 20 to 30 multisigs. Who are the owners? What's the threshold? What are the token approvals, etc. It's just a general like security thing. So instead of conclusion, a couple of advices. They're pretty basic in general. But please, if you are going to sign some multisig transaction, please check all the values. Please use the tools that you trust. They better be audited, but at least you need to trust those tools. Use some code data decoders to see what's going on within transaction that you are going to sign. And if you are not sure in any action you do, seek help from someone you trust. And of course, question yourself at every step. That's a pretty good advice in general. And what shouldn't you do? You shouldn't rush while signing transactions. It's still a very complex process, unfortunately, and you need to be careful at every step. And do not store $1.4 billion on a single multisig. That's like common knowledge, I think. And I hope that the industry learned that lesson. Spoiler, not really, but maybe it will learn it soon. And don't trust anyone, especially yourself, and especially me, I guess. So that's all. Thank you so much for listening, for your attention. You can follow me on Twitter. I'll have some pretty interesting content soon. And don't sign widely. Thank you.